the discriminant. Okay, so you know the quadratic formula is used to solve a quadratic equation. Okay, and the b squared minus 4ac part in the square root sign is what we call the discriminant. Okay, and the value of that can tell us whether a quadratic equation has no real roots or solutions, a repeated root, or two distinct roots. So none, one, or two. Okay, and all we're interested in is it a positive number, is it equal to 0, or is it a negative number? Okay, so taking each one of those in turn, let's look at the situation where it is equal to 0. Okay, so let's go back up to the quadratic formula. If the b squared minus 4ac is equal to 0, it means we're taking the square root of 0, which is 0. So all you're left with is minus b over 2a. Okay, that means we've only got one solution. Okay, repeated solution. Okay, and graphically what that means is the curve will touch the x-axis once and once only. Okay, second situation then is where the discriminant is greater than 0 or a positive number. And you know that you can take easily the square root of a positive number. So in this case we're going to get two answers, one using the plus sign, one using the minus sign. Okay, so one answer will be minus b plus the square root of b squared minus 4ac all over 2a. And one will be minus b minus the square root of b squared minus 4ac all over 2a, i.e. two distinct roots. And graphically then that means that the curve will cross or just touch the x-axis twice. Okay, two distinct places. Our third situation then is where the discriminant is less than 0 or a negative number. And if you think of putting a negative number into the quadratic formula in the square root sign, you can't do it. You can't take the square root of a negative number, meaning there are no real roots. You can't get any solutions from the quadratic formula. Okay, that means graphically then that the curve does not touch the x-axis at all. Okay, there are no real roots or solutions. Okay, so let's look at a few quadratic equations then and decide how many roots or solutions they will each have. So the first one here, 3x squared minus 5x plus 2 equals 0. So we're getting our values of a, b and c out of that just like you would if you were using the quadratic formula. So a is 3, b is minus 5, c is 2. And substituting those into the discriminant, so b squared minus 4ac. So minus 5 all squared minus 4 times 3 times 2 gives us an answer of 1. Okay, that number is not relevant really at all. It's the sign. Is it positive, is it negative, or is it equal to 0? In this case, it is a positive number. It is greater than 0, meaning there will be two distinct roots of that curve. Again with part B, a being 5, b being minus 7, c being 3. Substituting those into the discriminant, so minus 7 all squared minus 4 times 5 times 3 gives us an answer of minus 29. Okay, obviously this is a negative number, so it's less than 0. One where the discriminant is less than 0, there are no real roots to the equation or the curve. Okay. Looking at it in a slightly different format, okay, this time we're given a constant value a as our coefficient of x squared, but this time we're told it has a repeated root, okay, and we're going to work out that value of a. Now, if I know it has a repeated root, it must mean the discriminant is equal to 0, okay, so substituting our values into the discriminant, keeping a just as a in that, but I know it's equal to 0. Okay, so 20 squared minus 4 times a times 25 gives me 400 minus 100a equals 0. And that's just a simple equation that we can solve. Okay, adding the 100a to both sides to make it positive, dividing by the 100 then gives me the constant of the value a to be 4.